Welcome to solverfy.
So here we're going to first say that the pressure at the top here, we know that the upward force due to the air pressure on the bottom of the wing must be equal to the weight of the airplane plus the downward force due to air pressure on the top of the wing. And so then we're going to apply Bernoulli's equation. So the pressure at the top of the wing times the area plus the weight of the airplane itself equals the pressure at the bottom of the wing, BOT, times the area. And so we can say that then the difference in pressures between the bottom of the wing and the top of the wing will be equal to the weight of the airplane divided by the area of the wing. We're going to apply Bernoulli's equation. The atmospheric pressure plus the pressure at the bottom plus 1/2 times rho, the velocity at the bottom, squared, plus rho gy at the bottom equals the atmospheric pressure plus the pressure at the top plus 1/2 times rho, the density v, the velocity at the top squared plus rho gy at the top. We can then say that the velocity at the top squared would be equaling 2 times the pressure at the bottom of the wing minus the pressure at the top of the wing divided by rho plus the velocity at the bottom of the wing squared. And so we can then say that the velocity at the top of the wing would be equaling the square root of 2, and then we'd substitute this for mg over a. So it'd be 2 mg over rho times a plus the velocity at the bottom squared. And now we can substitute and solve. So then the velocity at the top would be equaling the square root of 2 times the weight. So 2 times 1.7 times 10 to the 6th kilograms multiplied by 9.80 meters per second squared. This would be divided by the density of air, 1.29 kilograms per cubic meter, multiplied by the area of the wing, 1,200 meters squared. And then this would be plus the velocity at the bottom, we know to be 95 meters per second quantity squared. And so the velocity of the air on top of the wing would be approximately 175 meters per second. This would be our final answer. That is the end of the solution. Thank you for watching.